using ScreenFlow to see if I can make this webcast. I'm going to go for a minute to my WordPress account. I'm going to Posts. I'm going to Something Old, Something New, and I'm previewing something that I'm going to incorporate this screencast into. Something Old, Something New, calculating and reporting effect sizes. Probably have to defer until this summer, mastering the intricacies of the new statistics championed by Jeff Cumming, and were one to go here, this would be a link to a very lengthy tutorial on the new statistics that's really very much epitomizing the book that Jeff wrote. However, here is the first attempt to introduce the concept, calculation, interpretation of effect size into my teaching. So I'm going to embed the screencast that I'm making right here, and I will list for the reader a number of effect size calculators I found useful enough to share with my students in Psychology 205. I'm going to concentrate on this that was developed by Paul Ellis. It's very elegant. I'm drawing from an example of an independent groups design, an independent T situation that's coming from Graviter and Wolno. It was a study in which individuals are either swimmers or they're soccer players, and we're interested in whether there might be a significant difference between individuals in those two sports that might have been incurred by concussions. In group 1, it happens to be the swimmers. The mean in some kind of neurological health is 9, and the standard deviation is 2.51. I had calculated these beforehand. And the degrees of freedom are 8. And in the second group, which happens to be the soccer players, the mean happens to be 6. The standard deviation has to be 2.45. And that's based on n, and then I'm clicking compute. Lo and behold, this nice piece of software developed by Paul Ellis then calculates Cohen's d. It's 1.21, and when I do that by hand, that's the same thing I get. It also calculates an alternative statistic, both r and r squared. R squared can be thought of as the proportion of variability accounted for. It's 0.27 here. The Cohen's d can be thought of as essentially being a number of standard deviation units between the means, so 1.21 standard deviation units. Well, what does that mean? Well, you can go to Result Whacker. And if you go to Result Whacker, Playful Paul says if you introduce d here, for example, and our d was 1.21, the sign does not matter, and we whack, it gives you a sense of how strong an effect it is. This is essentially following the recommendations of Jacob Cohen. Alternatively, had we put in the value of that correlation, notice it's r here, not r squared, you would be able to get a sense of the strength of the effect. So it's a very nice kind of thing. He also has this set up so that if you put in the value of the t, and I often use this when I am reading some journal article and I see statistics reported and I want to see whether or not they were done right. If I put in the t, in this particular case, the swimmers versus the soccer player, the t was 2.11, and I put in the respective degrees of freedom, and they were 9 and 6. And I do a compute. Here's another way to get Cohen's d. It's just a little bit different because of rounding, but that 1.19 is very close to that 1.21. There are many different effect size calculators, and there's still not a whole lot of agreement yet among statisticians. But the ones I've listed here are the ones that are probably most useful to the beginning researcher. I welcome feedback about this. I will be expanding upon this, but right now this is a brief introduction of this to my students.